everyone. So today I would like to talk about evaluation of diagnostic tests. So we use a table 2 by 2. So what's a table 2 by 2? We understand, right? 2 by 2, which is so let's say the column which is disease, and the first column which is plus, and second column which is minus, which is a have a disease. The patient truly have a disease, and the patient which is and the second column which is not patient, the second column which is a healthy people, which is the people no disease. And now in the row we have a test, so test positive, and that's the first row, and the second row is a test negative. So that's a table 2 by 2, right? So table 2 by 2 to compare test result with the actual prevalence of disease. So now we have a TP. TP stand for this the first cell, right? And that's the first square. That stand for the two positive. So two positive, and then after that we count about the four square, right? Four square, which is from left to right. So from top to bottom. This is, we name this as a square one. So square 2, square 3, square 4. Since square 1, which is 2 positive. What is 2 positive? So we will discuss that later. And the second square, which is false positive. And then the third square, this is a false negative. And the last square, which is the fourth square, this is a 2 negative. Okay, we will tell that later. Now talk about sensitivity and specificity. So fixed properties of the test compared to the PPV and NPV. What is a PPV? PPV stands for this positive predictive value, and NPV stands for negative, so predictive value. So now talk about, like we said, it's a disease in the test. Gotta have a false square, say 2 positive, and false positive, false negative, and 2 negative. So talk about more detail about sensitivity. Sensitivity stands for this ratio or rate. Remember, that's a rate, which is 2 positive rate. Okay, not just simply 2 positive number. It's not just the square number 1. Actually, this is a rate. So again, sensitivity is a 2 positive rate. So this what's that mean? That stands for sensitivity is the proportion of the all people with a disease who test a positive, or the ability of the test to detect the disease when it's present. Okay, so the value approaching 100% is desirable to exclude the disease and indicates a low false negative rate. So tests with high sensitivity are used to screen for diseases with low prevalence. So what's a formula? So we talk like that kind more complicated, but then simply we think about what is sensitivity. So sensitivity, the formula is equals what? It's 2 positive, right, over the total of 2 positive plus false negative. So what do they mean by that? So we see the total of 2 positive plus false negative, which is square number 1 plus square number 3. Square number 1 plus square number 3, that stands for first column. That stands for people actually have a disease. Okay, have a, for example, for a disease A, like that. So what is a 2 positive? Now we discuss 2 positive, that stands for, which is the patient have a disease A or B or C, something like that. And the test come up with a result positive. That stands for like diagnose correctly, right? They give the test positive for the disease A. But what is a false negative? False negative, that stands for which is like the, the patient truly have a disease, but the test unable to detect it, and the answer test result which is negative, that stands for false negative. The reason why false, the reason because truly the patient have a disease. Excuse me, sorry. Excuse me, sorry. So remember that. So how to remember the calculation for sensitivity. So sensitivity, just remember it's a table 2 by 2. Excuse me. So that's the straight nail of the disease. Truly have a disease. Okay, the patient gets 6 numbers of the sick people. Okay, which is the first column. Okay, that stands for that. To the equal the 2 positive over total of people get sick. People truly have a disease A, which is 2 positive plus false negative, or just square number 1 plus square number 3. Okay, with indicated disease in the column and test, which is 2 rows, disease in 2 columns. Okay, so that's a formula. Or just simply reality, we just think about like that, because it's a ratio, right? Which is stand for the percentage. Okay, so 100% like that, which is right what with the sensitivity. So we set is equal 1 minus for the false positive rate, right? What is a false positive rate? Oh, so I want to say again. I'm sorry. Is it because the string go too far? Right here. So this talk about sensitivity. So sensitivity, which is or just think about reality, like this because percentage, right? Which is a 100%, right? Sensitivity, which is equal 100%, which is 1 minus for the false negative rate, right? What is a false negative rate? False negative rate, just think about it's a logical thinking. We know this is a true positive rate. True positive rate stand for sensitivity, right? Then now, if true positive rate then equal 1 minus false negative rate, right? But now how to calculate what formula or how to calculate the false negative rate? Just simply for negative rate equals false negative over the total number of people get sick. People actually have a disease. All we can say is so over this is 2 positive plus false negative, right? Like that. That's a false negative rate. So again, for negative rate equal what? False negative. So over 2 positive plus false negative, right? Okay. So on the other hand, now they ask how you calculate the false negative rate. They simply have the same two formulas. Equal what? Equals false negative, right? The people which is have a disease, but the test come up with a negative result. That's unable to detect it, right? Over the actual numbers of the people have a disease A, something like that, which is true positive plus false negative, or equal 1 minus for sensitivity, right? And we know sensitivity equals 2 positive rate. Okay, now we understand clearly already, right? Now, talk about specificity. So specificity stands for that also this is for second column. That stands for what? This is a true negative rate. Give it my rate, right? Rate ratio. So now if we know that if true negative rate, so equals what? Equals the true negative over true negative plus false positive, right? That's therefore equal to square number 4 plus square number 2. Or we just can think about specificity. That's what we talk about the second column of the table 2, 2. Okay, that's therefore square number 2 and square number 4. But now specificity, that's therefore this true negative. That's therefore this healthy people, right? And the test come up with a negative result. And truly, that's those people don't have a disease A. Okay, truly. So the true negative rate equals what, which is a true negative, which is square number 4, right, over, so true negative, which is square number 4 plus false positive, which is square number 2. What is a false positive again? False positive, less than 4, which is that's a healthy people. But then the test come up with the result is a positive. That's a dangerous for those people, right? Because actually they don't have a disease A, B, C like that. But then the test come up with the result say positive. You see, you make the people so worried about something. So they really don't have that condition. But the test come up like that. So that's a test and say wrong. Stand for false, positive. Okay. Now we know that's a specificity, huh? So if we say like that, and then now talk about the formula again. So formula is equal what? Equal, which is a true negative, right? Over, so true negative plus a false positive, which is a square number 4 plus square number, so number 2, right? So in summary, so when we talk about sensitivity and specificity, that we talk about column. For sensitivity, there's a column first column. And specificity, now we talk about second column, right? Okay. Keep in mind that. So please give me the second. Sorry. I don't know. It's an easy, I guess. Okay, now as that we're done with the sensitivity and specificity, and also we know the concepts of the true positive, false positive, and false negative, and true negative. Okay. Now, we talk about now. We read about the theory here. What it say? Specificity is a proportion of all people without disease who have a negative test result, or the probability that the test shows that the disease is not present when the disease is not present. Okay. So the value approaching 100% is desirable to exclude disease. Okay. If specificity get 100%, that stands for so did not have a disease and indicates a low false positive rate. What is a false positive rate? Keep in mind this rate, right? So false positive rate just simply just equals, that stand for this square number 2 over false positive rate. Square number 2, right? over square number 2 plus square number 4, which is a 4 positive plus a 2 negative. Yeah, right. Or equal 1 minus for specificity, like that. Tests with high specificity are used for confirmation after the positive screening test. So now talk about specificity, and we know specificity, which is 2 negative, which is square number 4, over, which over what? The total of. Also talk about the sum of, the summation of 2 negative plus false positive, which is square number 4 plus square number 2. Okay, or equal 1 minus false positive rate. Again, I emphasize this rate, right? It's not just numbers. Rate, which is ratio. Okay. Right. So if specificity is 100%, so then false positive equals 0. That's correct, right? Because 100% equal 1, we know the formula specificity equal 1 minus for positive rate, right? And for positive rate, we see the ratio. So if sensitivity equal 1, which is 1, which is equal 1 minus 0. So that's why I have to be this for positive equal 0, right? Simply like that. And all positive results must be true positive. So right, because we know this for positive equals 0, then the all positive results, that's a true positive, just from the formula and from the table, and we can interpret it like that, Okay. So not difficult, right? Just from formula, we know this is specificity again is equal 1 minus false positive rate, right? And we know for positive rate equal what for positive over the healthy numbers. So now if my 100% stand for 1, so then we 1 equal 1 minus 0, right? So 0 that stand for which is for positive equals 0. If for positive equals 0, which is no 1 have a false positive, which is the test did not make any kind mistakes, right? Which is people healthy, is truly healthy, right? So that stands for no false positives, and then totally 100%, which is true positive. Okay, and that now talk about the PPV and NPV, right? Okay, so PPV stands for this positive subtractive value. So this is very directly to prevalence, okay, or pretest probability, higher high pretest probability, which is higher positive predictive value. So the higher probability, this stands for this not involved associated with the prevalence or pretest probability. So the what a formula for that? So we want to talk about that later. So about NPV, this is negative. It's a predictive value. It's a proportion of negative test results that are true negative. Probability that the person actually does not have a disease given a negative test results. Now we talk about the formula, huh? So talk about PPV. PPV, this is a positive predictive value, right? Now we talk about the row, okay? So the row which is square number 1 and square number 2. So if like that, then PPV will equal what? Equal the TP, which is 2 positive, over 2 positive plus false positive. And now talk about NPV, negative predictive value, right? That equals what? This is the name they tell like that, or is an equal? It's Tn, which is 2 negative, over 2 negative plus false negative, right? That's a square number 4 and square number 3, right? So in summary, talk about sensitivity and specificity, then we talk about first row for sensitivity and second row for specificity. So sensitivity and specificity, we talk about, talk about column. Sensitivity and specificity, that's stand for column. First column for sensitivity, second column for specificity. And now talk about the PPV and NPV, and we talk about the row, right? The upper row and the lower row. Okay, that's about it. So we clear. Now, okay, we got online again. Sorry about internet problem. Okay, now open this. This is a table 2 by 2. Okay, and we see the 4 squares. Squares number 1, which is 2 positive. Square number 2, which is false positive. Square number 3, false negative. And square number 4, which is 2 negative. So for TP, FP, FN, TN. So we see sensitivity, that's we talk about the first column. Specificity, that's we talk about second column. Now talk about PPV, that we talk about first row. And NPV, we talk about the lower row, which is second row, right? So now sensitivity equals what? Equals, it's a TP over TP plus Fn, which is square number 1 plus square number 3. Specificity equals what? Equals, which is 2 negative over 2 negative plus false positive, or square number 4 plus square number 2. Okay? Talk about PPV. PPV equals what? PPV is equals TP over TP plus FP, right? Which is 2 positive over the total number of test results answer is a positive. 2 positive plus 4 positive. And now talk about the NPV. NPV equal 2 negative over 2 negative plus false negative, right? So let's talk about prevalence of PPV, NPV. So are we clear about that? Okay. Now let's say talk about more table 2 by 2. Table 2 by 2 row. So table 2 by 2 diagnostic test in the table 2 by 2 like that mà. In medicine. So right here they say 2 by 2 table is a fundamental tool in diagnostic testing used to summarize the results of tests in relation to the presence or absence of the disease. It helps determine the accuracy of diagnostic. Right, how many minutes so far? Also 3 minutes, is it? Diagnostic test by calculating measures like sensitivity, specificity, and predictive values, which is PPV and NPV. So the table is structured with the gold standard 2 disease status on the top and diagnostic test result on the side. So which is disease, which is sick, healthy, test positive, negative. Here's a breakdown of the 2x2 table and its components, structures, rows. So represent the results of diagnostic test, positive or negative. Columns represent the true disease status, resemble presence or absence of disease, which is often determined by the gold standard test or reference method. So in the cells, like I say, squares. So this is a TB2 positive individual with a disease who test positive, false positives, which is a FP individuals without disease, but who test positive. That's dangerous, right? So false negative. For negatives, which individuals with a disease but who test negative. So this is a miss. They're missing something. True negatives, which is individuals without disease who test negative. So K calculations, sensitivity, this like we said is the first column, proportion of individual with a disease who test positive. So keep in mind this is a proportion, this is a ratio, this is a rate. They call also this as a true positive rate. So which is a true positive over true positive plus false negative, right? Which is cells number 1 plus cell number 3. Specificity, this is the second column. This is a proportion of individuals without disease who test negative. Remember proportion, this is a ratios. Okay, so then equal 2 negative over 2 negative plus false positive, which is cell number 4 over cell number 4 plus cell number 2. Now talk about positive predictive value. So predictive value, the proportion, this is the proportion of individuals who test positive who actually have the disease. This is a prevalence. So talk about the prevalence. Proportion of individuals who test positive who actually have a disease. So that's the thing for this is the first row. So this is equal what? 2 positive over 2 positive plus false positive, which is a cell number 1 over cell number 1 plus cell number 2. So now negative separative value, which is NPV, which is a proportion of individuals who test a negative who do not have a disease. So which is a 2 negative over 2 negative plus false negative, which is a cell number 4 plus cell number 3. Now talk about likelihood ratios. Describe how likely the test result is to be found in someone with a disease compared to someone without disease. Diagnostic odds ratio, DOR, a single measure that combines sensitivity and specificity. So DOR equals what? 2 positive times 2 negative over false positive times false negative. So how to understand this? This is a single measure combines sensitivity and specificity. diagnostic odds ratios DOR equals 2 positive times 2 negative over false positive times false negative. Okay, like that. So for example, diagnostic test 2 by 2 make calculation. Here, what here they give you. After that, show you this one's sensitivity to 54%, specificity high 97%. Okay, PPV, which is positive, so predictive value 46, negative predictive value 98. Oh, they calculate a lot. Positive level ratio, this one we did not mention yet. Oh, so many things in the statistics, epidemiology. Okay. Anyway, what I think that's all about it. So today, so I would like to talk about those things. But thank you very much for watching. So thank you. So see you next video.